Hi, welcome to my action research for the University of San Diego. My name is Adam Coe, and I'd like to share with you what I did for the past two and a half months. Some background information is I work at High Tech High. It's a school in San Diego that uses project-based learning. And what I wanted to know based off of the feedback here for my students is what things I can do to help them. And one of the things that they suggested, my students that is that class could be more challenging. So about a third of the class wanted the second semester to be more challenging. Some other responses include just have more challenging math, more math in the projects, and just a faster pace. So my research question wanted to focus on project-based learning and math in regards to achievement. And I teach Integrated Math 1 for the ninth grade level. In looking at various literatures and articles, I came across articles on both sides. On one side, they said that project-based learning in regards to math increases math achievement. For example, Jo Boaler did a study and she found that the project-based group scored higher on a national test in math than the other group that did not do project-based learning. There are also other studies, for example, Hanson and Gonzalez in 2012, that suggest more traditional methods of learning math lead to higher achievement. So with these two differing views, I wanted to see what would happen in my class. So here's our plan going forward. We had a choice for students to choose from. They could choose to do a project or they could do problems in lecture. And this kind of phase one is only 2 weeks. So after that, I wanted to do a longer study, maybe about 4 or 5 weeks, and that was phase two. And students actually got to choose which group they would be in, and they would be in that group for that period of time. After that, let's say 2 weeks for the phase one, they would take a quiz or an assessment or do a presentation, and then we would grade that. They'd also do a survey based on what they've learned and also giving feedback of how they think of this system, as well as how challenging they thought the math was. So let's start with phase one. Out of these 79 students that I have, 7 of them chose to do the project-based group. They learned about systems of equations and inequalities through a project called UP. They wanted to see how many balloons, different types of balloons, a 12-inch and a 5-inch balloon, it would take to lift a student up. They created a system of equations and inequalities, and they graphed it, and here's an example of a student work where they found this solution region being all possible outcomes of how many balloons as well as the budget restraint of how much it would cost. So these are all the possible solutions of the number of 5-inch balloons and number of 12-inch balloons that would raise a student up. A majority of my students did the problem and lecture group, so 92% of them. They just focused mainly on procedural fluency, so they were given packets of work in terms of solving inequalities, solving systems of equations and inequalities. I also differentiated the packets. So for example, the first one is just getting it. Students were just introduced to what inequality was and how they would graph that on a number line as well as an XY coordinate plane. And there were 2 other options as well. Students were able to choose, again, like I said, between groups, but also choose between what type of level they were at. They were not told which one, and they could actually do different ones as well. what I found was after 2 weeks, the problem and lecture group scored higher in their assessment than the project-based group. How the students were assessed were either to take a quiz or they were assessed by a presentation. Students would explain what they learn and know about systems of equations and inequalities. So the project-based students, they scored on average of 78%, and the problem-based students scored on average almost 85%. Also, the number of students, as you notice right here, are very distorted. So there's a very small group sample size for the project-based students. So moving forward, I wanted to try this again, but with a longer period of time, and I did that in phase 2. We gave the students the same choice. They were going to learn functions, and they could either learn it through a project, and the project was not necessarily focused around functions, but included functions as well. And the problem and lecture group, they focused on functions. So 17 students, so an increase of 10 students, chose the project-based learning approach, and we studied flight. Specifically, the 4 principles of flight being lift, weight, drag, and thrust. And within those principles, there are functions that students used as well as the equations. Their objective was to design a flying object and incorporate those flight principles as well as Newton's 3 laws of motion. They were assessed based off of a presentation and how much they incorporated their knowledge of these principles and laws into their design. The problem lecture group still was over 3/4 of the whole class. They learned about these 5 things about functions. What is a function? What isn't a function? Deciphering and graphing functions, looking at piecewise and exponential functions. They're about an average of 2 lectures a week, as well as 3, possibly 4 in-depth problems a week. What's different about phase 2 is that the problems that the problem lecture group did were more in depth. They did not require procedural fluency every single time, but actually encourage students to think more critically and apply their knowledge. So after 5 weeks, here are the findings. Problem and lecture group actually scored lower. They scored just above 80%, and the project-based group scored just above 86%. So they actually swapped. So in phase 1, the problem lecture group scored higher, but now the problem lecture group scored lower, and vice versa with the project-based group. Another finding that I tracked was the perceived level of challenge on a 5-point Likert scale. So I asked students after phase 1 to rate the level of challenge that they perceived the math. And in the beginning I mentioned that a third of the students wanted more challenging work. So 1 meant very little challenging, and 5 meant it's very challenging. So we're kind of in the middle here at 3.04 after phase 1. It wasn't too challenging, wasn't too easy. So in phase 2, however, there was a 12% increase. So from phase 1 and phase 2, there was a perceived increase in the level of challenging work. 2 things that come to mind are, 1, the topic that the project-based group looked into. They were looking into topics that were traditionally introduced beyond and after 9th grade. And the problem lecture group, they were doing more higher level problems that require them to do more critical thinking. So those are possible explanations of the increase in challenge level. So some conclusions and significance. As I mentioned, the project-based group scored both lower and higher, so I think that's significant because it wasn't a clear, decisive, I guess, outcome. There were mixed outcomes. Another significant conclusion that I found is that a majority of my students chose to do problem and lecture. And being at a school that does a lot of projects, I was surprised by this. And I think that's very significant because students tend to draw towards this more traditional approach. So I wanted to actually find out the reasons for students choosing each group. So I asked the students in the problem and lecture group, I asked them, why did you choose this group? About half said that they just like the way of learning math, I guess the quote unquote traditional way with problems and lecture, and they thought it was a better fit for them. About 20% of the students thought that something about the project itself wasn't really desirable. They didn't like doing projects, or they didn't like doing this particular project. Another 20% honestly said that it was easier than the project, so that's maybe some of the reason why that they came over and chose a project. And about 1/10 or 1 out of 10 students thought that it was a better method of learning than doing projects. So I asked the project group why you chose the group, and they said 80% of them said they just like doing projects. A lot of them in their survey said it's more interactive. They're able to not be, I feel pressure, I guess. With one student said they don't feel pressure with taking a quiz or a test, and they felt that there's more freedom and they enjoyed that. And only 20% of people in that group said there's something like they didn't quite like about problem and lecture. Some limitations of this study is we can't say for certain that, for example, this achievement was based on this style of learning, because there's different factors going on here. One is the sample size is too small for the project-based group. So if one student did really well or did really poorly, that affected the overall mean assessment score compared to the problem lecture group. Another reason why you can't say like, oh, this group is better than that group, or this style is better than that style, is the type of problems that the students did changed from phase 1 to phase 2. So phase 1 they were doing more numerical fluency, that was more straightforward and easier. And in phase 2 they were doing something more rigorous, there's more challenging. So that possibly could, cause the score to go down or up. So looking back at this action research, I can say that I learned a lot about myself and also the students. I think I wanted to go in answering the question of which one is better, project-based or problem and lecture, in terms of teaching math. And what I realized is that one of them is not better than the other. One of them is better than the other for certain students. And it would be a real disservice to my students if I only taught one way. So by providing a variety of ways to learn this subject of math, I feel that I'm giving my students a better access point and a better level of engagement, whatever that is, for them to learn math. So with this study, I am very proud on a personal level that I took all this data and analyzed it, and I feel like moving forward and looking ahead in my career, I can feel comfortable knowing that different styles of teaching should be used, and one's not better than the other, but definitely more than one style should be used. So thank you for being with me, and I appreciate your time in this.